over these two graph extravaganza problems. We're going to start with number 6a, and we're saying that a is greater than 0. That means a is what? Positive. And then if x is less than 0, that means x is what? Negative. This one's negative this time. Okay? Now if we graph this, if you're having trouble graphing, just let a equal to a positive value that's easy, 2. So could you graph y equal x minus 2? I think you could. Here's y equal x, like that. And then minus 2 is going to go 1, 2. Do you agree with that? Negative 2. Now let's get rid of the 2 and just call this negative a. Now the reason it's negative is because of this minus sign, not because of a. A is positive, but when you go x minus a, that's what's going to happen. Alright, so x minus a looks like that, goes through this y-intercept of minus a. How many agree with that? Raise your hand. You agree. Good. Now what I'm going to do is I'm going to look at the x clue. The x clue, or the domain, is x is less than 0. Or you could say negative infinity up to 0. That means that part of my blue line is going to disappear down to there. And it's not equal, so we're going to keep an open mind, an open circle here. And now what will the range be of this? What will y be? Here's the highest y, here's the lowest y. Negative infinity is the lowest y. And it's going to go all the way up to what? Y. Negative a, yeah. So y is going to be less than negative a. Did anybody get those two? Did they get those two? Yeah. Yeah. Question.
Could you technically have it anywhere in the line depending on the numbers you use?
Could you what?
Have it anywhere. If you use a different number, say like 1 instead of 2, would it be wrong to just pass it?
No, this could be anywhere down here you want, but we'd have our bases covered because it's a. So if it were 1, it would be up here, negative 1. If it were 4, it would be here, negative 4, and so on. It's still less than negative a, and x is still less than 0. Does that answer your question? All right, let's do this other one, and this was the one that you guys did an amazing job with yesterday, trying to figure it out. Is now what we're going to do is we're going to think about this in its most basic form, and the most basic form is the greatest exponent, x squared. Show me with your arms x squared. Okay, everybody? Everybody, thank you. What's negative x squared? Down, right? So what we're talking about here is an upside down parabola that's somewhere on this curve. I don't know where. Well, we're going to find out where, and the way we're going to do it is we're going to take out an a and an x out of this algebraic statement. And if I take an a and an x out, I'm going to have an x here. And if I take an a and an x, I'm going to have an a here. And what's left on this one? Take out an ax, what's left? There's my x. Good. All right, so let's go back in time. If I had y equal to x times x minus 1 times x plus 3, what values could I get for x to make y equal to 0? What's one value for x? 0. What else? 1 and negative 3. Now the way this works is that if x is 0, here's what you would be saying. 0 times negative 1 times 3 is equal to 0. Is that true? Sure. And if we had a 1, is 1 times 0 times 4 equal to 0? Is 0 times, negative 3 times negative 4 times 0 equal to 0? Yeah, anytime we have 1 0 in a multiplication, the whole thing goes to 0. So what we are saying here is that if we're trying to find the x-intercept, which we are here, what values for x will give us that? X equal to what? A, yep, because A minus A is 0. Brilliant, that's a tough one to find. And then the other one? 0. So we're going to say that this graph is going to go through 0 and it's going to go through A. So I'm going to move this graph, shift it, and drop it so that it does just that. We know it's upside down because it's minus and it's x squared, it's a parabola. So, and it goes through x equal to A and x equal to 0 to get y equals 0. Now we're going to go to the problem, and it says that x, well, A is again greater than 0, it's positive, no change there. But then this is interesting. X is less than or equal to 1/2 A. So what's so special about A over 2? What's so special about it? It's 1/2, and it's underneath the peak, or the max. So we want to find out what this y value is, because looking at this, the domain is just going to be x less than or equal to A over 2. We get that, because that's what it tells us. But what we don't know is what is that range. Well, the range here is going to be less than or equal to something. And did we do this one yesterday? Did we find it yesterday? Oh, good. So what you're going to do is you're going to say, all right, let's look at f of A over 2. And wherever you see an x, put in A over 2. Wherever you see an x, put in an A over 2. And what's 1 minus 1/2? 1/2. Is that the same as 2/2 minus 1/2 is 1/2? But, so we're going to say that this is going to be A times A is A squared over 2. And then 2/2 A minus 1/2 A is 1/2 A. A cubed all over 4. That's the y value of the peak. We did this before, didn't we? All right. Any questions on that? Yeah.
How did you know where to graph A? Like when you put it on the x-axis?
How did I know this parabola went through 0 and A?
Yeah, or like how did you know where to put A? It doesn't matter.
Oh, it doesn't matter. It's a made-up number like 4 or 54. Yeah. Sure. Okay, so now we can just do our range. Our range is going to be as high as A cubed over 4 and goes to negative infinity. So my answer to that are these two. So what I did for G is I took the square root and I moved it to the right A, and then I moved it down A, making it over A, down A. For the absolute value, the A on the top from E doesn't make any difference. It just makes it a little bit steeper. But then when you add A, it's going to move this from down here up to A. Started down here, moves up to A. So what's the domain for G? What do you think? What's X going to be? You just look at the picture. X is going to be greater than or equal to what? A. Brilliant. What's the range going to be? Y is going to be what? Greater than or equal to? Opposite of A. You got it. Because A is positive, it's dipping down, so we'd say the opposite of A. How many got that one right? Got any questions that I can help with? Yeah.
Why on this one is it greater than or equal to, but on the last page, on A is it just greater than?
That's a great question. The reason for that is that square root is different than, square root is different. This one said here, are you talking about this first one?
Yeah.
Yeah, this one says it's less than, it's not equal to, you don't see an equal there. But this one, can you take the square root of 0? 0 times 0 equal to 0? Yes, so we would say you can take the square root of 0. So just because of this special function, you can take the square root of 0. That's why it can equal that. It's kind of nasty. And that x is greater than or equal to a, y is greater than or equal to a. Let's take a look at this next one. Now, let's look at the domain. What's the one value you can't have for x? What's the one thing you can't have for x? 0. And you can see you can't divide by 0. So you would say x, well, here's the way I would do it. I would go negative infinity to 0, union 0 to infinity. That's how I do it. There is a quicker way, and you write an R, which stands for real numbers. Now, this is an independent Republican. It isn't IR. It's just an R with a bar next to it. You would say it's all real numbers except what? 0. So either way, you can write it either way. I love it. Both are good. What's the range for this one then? Let's use my little method here. All reals except what for the range? A, yeah. Or you could say negative infinity to a, union a to infinity. Now you probably like this way, don't you? It's okay.